Hello and welcome here at S2D Days. You are now in the presentation Learn what Storage Spaces Direct is capable of by benchmarking the setup. My name is Carsten Rachfahl and I'm one of the Microsoft Cloud and Data Center Management MVPs. Furthermore, I'm also an organizer of a conference in Germany called the Cloud and Data Center Conference Germany. Um, I'm the co-founder of the Hyper-V and hybrid cloud community in Germany. I'm one of the two Hyper-V amigos with my friend and colleague Didier van Houye from Belgium. We do videos about some great Hyper-V and Veeam stuff. If you want to follow me at social media, I am so old I can only tweet, so my handle is Hyper-V Server. And if I'm not doing community work, I'm one of the two CEOs of a German SI called Rachfahl IT Solutions, and that's for 28 years now. And if you want to look up what stuff I'm doing, you find all my work at the blog hyper-v-server.de. So let's right dive into the topic. And we talk today about benchmarking, especially benchmarking a storage spaces direct environment and why that is so important. Before we start, I want to mention that our experience, what I'm talking about here, is from more than 100 customer implementations of storage spaces direct. And we do in every environment, we do benchmarking because we see a lot of there that is otherwise not possible to see. First, why benchmarking? Why do we benchmark? A customer has, if he buys a storage basis direct solution, it's mainly about storage, and most of the time he's coming from a storage system. And many of the customers have performance problems with their older storage systems. So it is nice to show a customer what storage basis direct in his environment can really do. So the customer gets a good feeling and is assured how good storage basis direct is and that he has no problems with his workload. So we build confidence with benchmarking, and the most important part, we find errors when we do benchmarks. And if we drive a storage basis direct system to the edge, to the limits, you see things that you don't see if you start up 2, 3, 5, 10 VMs and just let them run. So this is why we do benchmarking. But everybody who does benchmarking has to know some facts. First, every benchmark influence the results. So if you do benchmarks, for example, on a system where you have VMs running, you will influence the performance of those VMs and you also influence your results. In Germany, we have the saying, wer misst, misst, misst. And that means someone who is benchmarking something is not really measuring the right thing. So another thing that is important when you do benchmarking, use realistic workloads. A non-realistic workload is 100% read benchmark with 4Ks. 4K IOs, that's not realistic. I don't know any customer who has only read in his environment. Maybe someone like Netflix or Google with YouTube has only reads because they upload a video only once and then it's consumed by the customer. So they read them from their systems and deliver them over the internet. But a usual customer in a virtualization environment doesn't have only reads, and reads are much easier than writes. So we do all our benchmarks with 8K, not 4K, because 8K is much more difficult for a storage system if we don't use 4K, because 4K, everything is 4K now. So you have 4K sector sizes on the disks. You have 4Ks in the operating system or larger ones. So we choose to not do 4K, we do 8K, and we want to have a realistic write part. So we do 30% write at least and 70% read. A good storage spaces direct implementation depends on the underlying network. To be exact, the east-west network, that is a network between the storage spaces direct nodes in a cluster. And Microsoft recommends at least to have two 10 gigabit network ports. I would say more is better, but two 10 gigabit is okay. And I would also recommend to use RDMA. If you do Rocky with Mellanox, for example, or IWAP with Cavium, for example, doesn't really matter, but you have to have a high performance network as the foundation for storage bases direct implementation. So now it's a question, if you set up storage bases direct, how can you test your network? And that's quite easy with an hyperconverged S2D implementation. Hyperconverged means you have Hyper-V running on your S2D nodes. And then you can, of course, create a Hyper-V VM and use the live migration to move a virtual machine from one hypervisor to another. And live migration can leverage SMB3, SMB3 multi-channel or SMB3 direct. And we are talking, when we do a live migration, we are talking about memory to memory transfer. So this is usually much, much faster than the network you can provide. So what we do, we create a virtual machine with a lot of memory, in this example 200 gigabytes. We don't install an operating system in this virtual machine. We just start it, and before we start it, we change the stop action to turn off, because when Hyper-V starts a machine, and it's usually as a stop action safe, it will reserve the memory in the configuration directory. So if we have a 200 gigabyte virtual machine, it would reserve 200 gigabytes, and most of the time you don't have this space in your C drive. And we do this test usually before we set up storage spaces direct. So we only have our C drive. And then we start the VM and we change the live migration of the hypervisor to SMB3. And then we live migrate the VM and we look into the performance counter. So let's just do a demo. So here we are on one node of a 4-node S2D cluster. I have a virtual machine running here that's in the boot screen. And if we look into the settings of the machine, we see we have 280,000 megabytes of memory, so roughly 270 gigabytes, one processor, no hard disk, no network adapter connected. So the machine has just started and is looking for an operating system, but that is not necessary for a machine to really to allocate all the memory it needs, and we can then do a live migration with the machine. So here I have opened Task Manager. You see the machine is not running on this host, it's on the third S2D cluster node, and we will now start a live migration from the third node to the node where we are connected to. So I choose the first node here, start OK, and now the live migration will first allocate the 230,000 megabytes. And you see that here, the memory usage is increasing. It's now at 100, 200, gigabytes, and when it's all allocated, the live migration will start, and the movement of the data really starts when it jumps to 52%. So for that, I open Performance Monitor. Here you see the RDMA activity counters of my two network cards, the two network ports that are used for SMB3. These are RDMA cards, 50 gigabit NIC ports on a dual port adapter. Unfortunately, the dual port adapter is in a PCI Express 3 8-lane port, so an 8X port, and this port has only 64 gigabits. So we can't leverage both 50 gigabit ports and get all the data through that. We are limited by the bus. But here we see now we are moving the machine from the node 3 to the node 1, and we see now the inbound bytes per second, and these are 3 billion bytes. So 3 gigabytes on this adapter and 3 gigabytes on that adapter. So that's really great. That's over 48 gigabit. That's not 64, but 48 gigabit. But what's important here, if you look at the network, that these numbers are nearly equal. They should be very close together. And that's a good sign that your network is correctly configured. When you do the live migration with the east-west traffic, where we have the storage traffic that we should see now again, the numbers are not equal because the traffic is unevenly spread over both adapters. But if you do live migration, we will consume all the rest from the storage traffic up to the maximum that is possible, and then you should see very equal numbers. So now the machine is moved here, and the system is now deallocating the memory on the third node. And if the memory is free there, we will see the connection to the console again here, and our live migration is finished. So to sum up, I use the live migration all the time to test what's possible in the network. We saw that with 3 gigabytes per adapter, so in some 6 gigabytes, so over 48 gigabit. But the more important part is that the multi-channel is spreading the data very evenly over both network ports. So now let's switch to testing the storage performance that we can get out of VMs. And we have two methods that we use for that. One is creating a VM with a test tool that gets all the I/O one VM can get from the storage system. So in our case, the storage basis direct system. And the second method is to create a bunch of VMs and get all of the I/O that is possible in the storage. So for the first thing, we create usually a benchmark VM, and for that we use a tool called Iometer. Iometer is rather old. It was last changed in 2007, and I always joke this was before the iPhone. The first iPhone was invented. So it's old, but it's still good because you can specify what test you want to do. And the most amazing part is you really see immediately what I/O you get. So if you look at the picture on the right, you see we have a machine here, we have a gauge where you can see we have now 7,413 I/Os per second. And usually I create a small virtual machine, let's say with 40 gigabytes of disk space. I install Windows Server 2016 in it, standard edition. Usually, if I want to, I configure how to log in. So if I start up the machine, it's just logging in and starting the process, but that's not really necessary. And then we download Iometer. It's a small zip file. It only has 2 axes in it. And then you can start it, configure Iometer, and you see the results after some minutes. So as an example configuration, you create for a virtual machine with 2 cores, 1 gigabyte of memory. We created 10 gigabyte test file, 2 workers. We use 10 outstanding IOs, and then I usually test 8K blocks, as I always do, with 50% read, 50% write, of course, and 100% random. So we jump into a demo. I'm here on another hypervisor. It's another S2D node from the Tarox cluster. And here I have created a benchmark VM. Let's look into the settings. So you see we have 1 gig of RAM and 2 virtual processors, no network. So let's just look into the machine. Open it here. And I'm now in the C drive of the operating system. And you see I have downloaded the Iometer zip from the internet and unpacked it. Then you get 2 files. The third file is a configuration. I prepared this demo a little bit so we don't have to configure it from scratch. I also created a 10 gigabyte test file. It's in C iobv.tst. So let's just start Iometer. Double click Iometer. I run it. Let's get rid of the Explorer. So here you see we are on the nice old school interface, but that's not bad because the benchmark tool does what we need to do. So first you have to assign the C drive to every worker. If you forget a worker, it will not do the test. Then I specified 20 million sectors. The sector size 11 years ago was 512 bytes. So to get a 10 gigabyte test file, we have to choose 20 million sectors. And then I changed the pattern to pseudo-random. So it will generate a pseudo-random test file. So then we go to the access specification, and I told you I always do an 8K test here, and there is no 8K, so we have to create one. And I choose usually the 4K aligned, 50% read, 100% random. So I click on Edit Copy. I change the test sector size to 8 kilobyte. I rename the test to 8 kilobyte. Get rid of this one. And then we see here we have a 50% read, 50% write workload and a 100% random. So I click OK. And then I scroll down. The new test is here. And I align the new test to both workers. So you see it here. Both have it. Let's save the setting for later so you don't have to create the 8K again. And then we go to result display. And this is the default configuration, so it will update never the screen, only if you stop the test. I change it to 2 and I say show me the last update. And then we can kick off the test by clicking on the flag here. And now it's starting the test. So now you see we have around 4,000 8K IOPS, fully random, 50% read, 50% write. But this is, of course, not the maximum a virtual machine can get, because this virtual machine behaves very brave. So it will send one IO to the storage, or it will read one IO, and it waits until it gets it. And if it's writing an IO, it waits for acknowledgement that it is written. But this is not really that we can get all the storage system can do. So let's change the default settings. And I told you in the screen that I use 10 outstanding IOs here. So let's see that every worker has 10 outstanding IOs. I start the benchmark again. And we now see we have around 17,000, 18,000. That's not bad. It's not excellent, but it's not bad. So if you want to have more IOs, you can always increase the workers to get the limit of your system. So let's go here, click on worker, say duplicate. So we have now 8 workers. They all have the same settings. They all go to the same test file, and let's start our test again. I'll see what we get now. So now we are at 44,000, 49,000. And you may say, okay, 8 workers, parallel workers, doing every 10 outstanding IO, that's not a realistic workload. And that's true. You usually don't have a virtual machine that does this IO. But you see, our storage system can give us that IO if we would have a virtual machine behaving like that. Okay. So the Iometer demo we did already, and here I have an example for you, one of my best benchmarks so far, an Iometer that running in 1-2 core VMs with a lot of workers that does 4K IOs, and I got 120,000 4K IOPS, 50% read, 50% write, all random. So this is only an example that you see what storage basis direct is capable of. I told you we do another benchmarking tool in S2D, and for that we use VMFleet. VMFleet is a test suite from Microsoft that is part of the disk speed test tool. Disk speed is free, is open source, and you get VMFleet with it. It's in essence, it's a bunch of PowerShell scripts that enable you to create a lot of workers, a lot of VMs that do disk speed tests, and you can specify, let's create 10 workers or 20 per node. So in a 4-node S2D cluster, for example, you have maybe 80 workers, and then you have a visualization for your tests. It's called a watch cluster PS1. It's a PowerShell script that grabs all the data from Perfmon of the different nodes and displays them. And you see immediately what's going on in your storage spaces direct scenario. And you can change the tests. So every worker VM is looking in a share on the host. And if you change the test file or create a new test file, the workers will immediately load this test file. And after a minute, for example, all the workers are doing the new test you specified. There's even one more thing. You can do sweep tests when you want to test different patterns automatically. So let's say you want to know how your storage spaces direct system behaves with a 4K, with an 8K, with a 16K and a 64K workload. For example, then you want to know, let's say, how does it with 100% read, 75% read, 50% read, and 100% write. And you want to know with one thread and one outstanding IO and 4 threads and 4 outstanding IOs. There are a lot of permutations of all these values, and it will create all the tests for you and do them in a 3-minute window. So it will start up the test, it will measure the test, and then it will shut down the test. And after hours, for example, you find a lot of files in the result directory where all these tests have been done, and you find a result file for every VM there. So without further ado, let's go to the demo. So I'm here in a demo on a 3-node hyperconverged storage spaces direct cluster. I have deployed 30 VMs per node. So you see here 30. Let's go to the failover cluster. Here you see all the VMs. We have 91 roles. If we scroll through, 91 roles, 90 test VMs, and our benchmark VM. So let's just look in one of those test VMs. Here we see it is started, but it is in pause mode, as all other 90s are. So they are not generating IO, they're just waiting to get the go so that I clear the pause mode, that they can create or really test the storage system. I have another PowerShell script here. We talked already about the watch cluster script. And you see here we have the connection to all the 3 nodes in the S2D cluster. And this script will grab all the perfmon counters, sum them up, and display them. So I get an update here every 2 seconds, and I added other counters. Usually if you only started, you get only the CSVFS counters that are the most important, but you also see some cache counters, some software bus layer counters, and for example, how much the hypervisors are used. So here we see 16% of CPU usage. Here we have an IO still running, and that is our benchmark VM that is still running on one of those hosts. So let's go here, click on the benchmark VM, stop it. So let's click here and do stop. And then our IO should be gone. So here you see the IO just stopped. And now let's clear the pause mode to get some action going on. So I clear the pause mode, and immediately you see that the benchmark VM here grabs the test file and starts the IO. And here in our watch cluster, we see we have now 500,000 IOPS, over 350,000 read, and over 150,000 write. So this is a 70-30 workload. And here we see the bandwidth. So we are moving in the moment 4.44 gigabyte, 4,000 megabytes per second into the system. The very important counters are here. The read latency, that's good. It's it's around 1. It should be below 1. And the write latency here is not very good. And this is, in the moment, a problem in Windows Server 2019. On this hardware with 2016, you don't have the problem. So the hardware is okay, the device is okay. But in Windows Server 2019 is some flaw. And Dave Kahula blogged about it recently. So go to his blog and read about it. So what I can do to get a decent workload here, I change this file. Uh, I tweaked disk speed so that I can limit the IOs a VM is doing. So I saved now this file, and we will see that immediately our worker VMs grab that, and they will load it and do the new test. And we will look here at the watch cluster and just see what's happening. So they are not stopped yet. It takes a bit. So now they load the new file. Here you see we have the C run disk speed with the bytes per thread per millisecond. And now all the VMs are grabbing this file and starting up the new workload. And you see now we have only 380,000 IOPS. That should be 90 times 4,000 IOPS. But what's important here, we have a nice write latency. And you see here, the CPUs are in average 59% used. And if you look here in the task manager, you see that. So let's go back to the slides and sum up the presentation. So I didn't really have the time to talk about VM fleet in depth, so I want to hint you to this Hyper-V Amigo showcast. The Hyper-V Amigos is me and Didier van Houye, another MVP from Belgium, and we did a 2-hour Hyper-V Amigo showcast about VM fleet, how we set it up, how we show different tests, and so on. So I strongly advise you, if you want to do a VM fleet test, go to this website and look through the showcast. So there are some more information you can get out of a storage basis direct system or a Hyper-V system. There is a feature called storage course flow, where you can guarantee or limit the IO of a VHDX. But if you don't guarantee or limit it, there is a nice PowerShell command called get-storage course flow, where you can just see what's going on in the moment. And here in the example, you see I have 6 VHDs. It's a benchmark VM generating IO. And we see here 15,000 for this example, 15,000 per second, an average over the last 5 minutes. And it had a 0.5 millisecond latency, and it moved 123 megabytes of data was moved in this VHDX. There are more counters. For example, the get storage course volume PowerShell script shows you counters that sum up the volumes. So you see here, this volume has 118,000 IOPS with an average of 0.6 millisecond over the last 5 minutes, and we moved 491 megabyte per second over the last 5 minutes. Watch cluster, you already know, we talked about that. So there are some more performance counters, or watch cluster gets a lot of information out of the performance counters. We talked about the RDMA activity counters, very important. There are S2D tier counters, so storage-based tier counters. If you use the multi-resilient volume or the mirror accelerated parity, how it's called today, you can see in those counters how the tiers are used. If all UIO is coming out of the performance tier, or if the capacity tier is also used. And then we have the information of the hybrid disks. A hybrid disk is a combination of a part of a caching device, let's say, for example, an NVMe, and a part of a capacity device, for example, an HDD. And you see a lot of information here. So I want to grab the chance to give you a hint to my webinars, my free webinars that I do nearly every month in English. And here you find the website where you can sign up, and you can see over, I think, 15 to 17 webinars already. So I want to thank you and wish you a nice rest of the S2D days. And thank you for watching my session about benchmarking a storage spaces direct system.